Hey, and welcome back. So last time we took an overview of the entire project. So hopefully now you can see how things are starting to connect. Now we briefly looked at something called libraries. Excuse me, or object. We called it code libraries. I'm calling this whole thing libraries. So what I said before is that the main logic is in there. So the way I handle tiles, the way I load rooms, the way I move sprites around, all that logic, all that code for those things is in that libraries folder. And mainly what those libraries are files filled with subroutines. So I have separated my variables. I have my constants over here. I have tables over there. So I have separated them like that. And then I have this other thing called libraries. And in those files, I have something called subroutines. Now we haven't talked too much about subroutines. I have briefly mentioned the word, but we don't know what it is. So we're going to start looking at subroutines today, and then we're going to look at macros after that. So first of all, subroutines. Here in my game code file, I have my main label and I have my game loop, my empty game loop. Subroutines are basically they are routines, like you can hear from the name, but they are pre-written routines. Excuse me. Pre-written routines that have their own label, and they can be short, they can be long, but they have a purpose. They should have a purpose. So I think it's best if I just start by showing you an example. So now I'm just going to make an example here called my subroutine, and every subroutine needs to end with RTS. Now we have seen RTS before. I said that RTS stands for return from subroutine. If I write this at the end of my code, so we have seen it before. If I just change the border color, I make a small program, change the border color and write RTS at the end, then that RTS is just going to exit my program and go back to basic. But in this case, it's not gonna do that. Why? Well, let me show you here at, if I do something here over at main, if I go up to my main part here, now I'm going to say jump to subroutine. That's the mnemonic JSR, my subroutine. So this JSR, jump to subroutine, my subroutine. My subroutine, that's specified down here. Right now it does nothing, except it has a proper ending, RTS, which means return from subroutine. So let's take a look at this again. JSR, my subroutine, jump to subroutine, my subroutine. All right, so we jump down here and we start to do whatever was defined in this subroutine. And then we get down here, RTS, return from subroutine. That means return from wherever you started from. So when we say RTS, we go back here, and then we continue the code down here. So it's not like the normal jump. You remember we have something called JMP, right? Now JMP, jump, that's just going to jump to some place in code. So jump to game loop, for example. This is just going to jump down here, and that's it. So these two are different. because this JSR is going to expect an RTS, so that when the subroutine is done, we reach the RTS here at the subroutine, then we go back to where we started from, where that subroutine was launched, and we continue the code as normal. So we don't just jump somewhere, but we jump somewhere, do whatever specified in that routine, and then return from subroutine. So we return back here and we continue the code as normal. So hopefully that makes sense. So what's the point of these subroutines? Well, let's say you have something that you are going to do a lot. You're going to do those things a ton of times in your game, in your program, whatever. Let's say in our game, drawing a tile on the screen. Drawing a tile on the screen. You know, we want to draw our background graphics. So drawing a tile on the screen like that takes a little bit of code. So I don't have to want to write the same code over and over again. Okay, I'm going to write some code to draw this tile. All right, now I'm going to draw some code to write this tile. I'm going to draw some code, write some code to draw this tile. You know, that's crazy. Writing the same code over and over again. We can't do that. First of all, that's, if we do it that way, that's going to fill up memory very, very quickly. So that's one reason. Another reason, of course, is that you have to write the same thing over and over again. It's going to become boring for you. And also, by writing the same thing over and over again, there's a very big chance that you'll make a mistake in one of those. So they probably won't be 100% identical. So the point is, making subroutines that performs a specific task is a really good idea, both in terms of memory usage, because we only write the routine once, but also, as I said, by writing the routine once, we know everything that's in there. Maybe there's a mistake in there, but it's just one mistake, not several mistakes, because you wrote the code 10 times. So hopefully that makes sense. So that's what the subroutine is. And let's not forget, we run the subroutine by writing JSR and the name, the label name. So that's gonna start my subroutine, perform whatever was in my subroutine, and when we reach RTS, we return back here and continue the code. So that's a subroutine. So now let's look at an example. So I've made a little program here to move this guy around on the screen. So we have seen this kind of thing before. It's nothing special really. I'm moving a sprite graphic around on the screen, and as I said, we've seen that before, but let's take a look at how I'm doing that in this case. So start by all of these labels up here. Let's not worry about that for now. We also are jumping to a subroutine here, but we're going to come back to this special guy in another episode. But if we go down to my game loop, here is my game loop. Now here I have a few JSR, a few jump to subroutine. The first one here is called delay. So that must mean that I have a subroutine somewhere called delay. So let me see if I can find a subroutine called delay here. Yeah, sure enough, there it is. So here is a subroutine called delay. So what's going on in here? Well, apparently it's just two loops. So if you remember from this sprite thing, we need to slow down so the sprite wouldn't move so fast. So this delay subroutine is just wasting time, really. It's just a loop inside another loop. Just goes on and on like that to waste time. First, so yeah, the one loop goes 250 times, the other one goes 100 times. And when all of those loops are done, there's an RTS down here, which we just learned will bring us back to where this delay thing started from. So RTS, it's gonna bring us back here. So we started the delay subroutine here. When that reached the RTS, it returns back here. So then we're at this line. And once again, there's a JSR in here, jump to subroutine. This time the subroutine is called read joystick 2. Alright, read joystick 2. So here is that subroutine. Read joystick 2. So I'm going to jump to that subroutine, and this subroutine reads the joystick input. Now we looked at this before as well. So that's what this routine does. And of course it does something if I hold my joystick left and right and so on. But all of that's going on in this read joystick 2 subroutine. We do all of that, right, do all of that, and then we get down here to an RTS. So once again, RTS, return from subroutine. That means that when that routine is done, we're back here where we started from. And we continue on the next line. That just says jump to game loop. So that means we just jump up here and we run those two routines again. So that's those are some examples of using subroutines. Having some specific purpose, some job you want to perform, and you know that that's going to be done many times. So we don't want to write that code 10 times. So in this case, I made a read joystick 2 subroutine, put what I want to have happen in there, and just every time I want to use that, I just JSR the name of the subroutine. So let's look at one more example. So here I am in my tile library. So you remember I had a file called tile library. I think we looked at it last time. In my tile library.asm, I wrote a heading like before, just because it's convenient. But here is something new. We have something here, tile with capital letters and this colon, and then this thing, sort of a curly bracket. And if we go all the way down, there's a curly bracket in the other direction at the bottom. What's this all about? This is something called scoping. So there are many ways you can do this, but you can make a scope like this. So by starting with, by writing a label and writing a curly bracket, starting curly bracket like that, and an ending curly bracket like that. So whatever comes between those, you can write whatever labels you want in there. So that means that I could have two different tile labels, maybe tile 1 and tile 2. So I could have tile 1 and tile 2, for example, something like that. And here in okay, let me just do it right, something like that. So I could do something like this with scoping. Now normally I can't make labels that are called the same as another label, the assembler would complain that say, hey, you can't have draw char, there's another draw char already. So we can't normally have labels with the same name. But because of this scoping thing, starting a curly bracket and ending curly bracket, so what's between those, that's in that scope. So in this case I could have a draw char here and a draw char there, as long as these labels are different. Now for me, I'm not going to use it that way. I don't have a need to make labels that are called the same. I like to call my labels different things. But there's another thing. There is another reason that I like this scoping thing. Now, for anyone who has programmed in Java or some kind of object-oriented language, you might see some familiarity here. But since I separated my code, so for example in this case, this is my tile logic, tile code. Then I have some sprite code, sprite library, and room library, and so on. Since I separate them like that, for every one of those files, for example in this case my tile library, I write a label, start by writing a label like this, tile, and I write a starting curly bracket, and I end with an ending curly bracket. So inside my scope there, that's where I make my subroutines. Alright, so what am I getting at? Why is this such a nice thing? So this also has to do with how big our project gets. So if I now make, let's see, if I make another file here, and now I want to run this draw char routine. So then I say JSR, jump to subroutine. But since I did this scoping thing, I have to write the name of the scope here, so this label, then dot the name of the subroutine. So in this case that would be jump to subroutine tile draw char. So this is how I'm going to run this subroutine. This subroutine is in the tile system. So for me, this makes it tidy, because first of all, let's say I did the other thing where I had oh, let's see here, tile 1. So if let's say I had something like that, so this shows how so this is one of the benefits with using scoping like this, because here I need to do this, and if I had several of these, I could do something like that. So if I have one scope that's called tile 1, there's a subroutine in there called draw char. Then I have a scope called tile 2, there's a subroutine in there called draw char. So those are called the same, but since the scope names are different, it's really not a problem. So we can do it this way. Tile 1, there's a draw char, tile 2, there's a draw char. But like I said, that's not how I use it. So I just wanted to remind you, for me, the handy thing, like I said, when your project gets big, let's say I have a routine that's called, let's just say I'm not very good at naming labels. So I have a subroutine called update. Alright. So somewhere in my code I specified a subroutine called update. It made so much sense at the time. When I sat there programming this update routine, I'm gonna call this subroutine update. That's gonna make perfect sense. And it probably made sense at the time. But then later on, after a few weeks, I continue writing my code. And somewhere in the code it says here, jump to subroutine update. Now I'm starting to think, oh, update. Where was that subroutine? Oh, so now I'm not sure where that subroutine was located, because my code has gotten big, and the only thing I know here, because now I'm looking at some code that I wrote a few weeks ago, and I just see this JSR update, and I can't remember where that update was. And let's say that there's something wrong with that update routine as well. So I don't know where to go to fix it, so I have to start searching all over the place. Now, if I do it another way, let's say I do it this way. Now I am, let's say it was that so-called update routine. If I did it this way, which is the way that I prefer to do it, by writing scopes like this in my libraries. So by doing that, I can see that, oh, this update routine, that's in my tile library. So just by doing this, I can immediately see where the routine is located. Here, I have no idea. I know that somewhere in the code, somewhere in all those thousands of lines of code, there's something called update, but I don't know where. If I do this, I immediately know, right, that's in my tile routine, in my tile library. So then, maybe my tile library is really big, but at least I have narrowed it down to my tile library. So for me, that's probably the biggest benefit with this scoping thing. That I know exactly where the different subroutines are. Okay, so I hope that made sense. This is again in line with our keeping things tidy strategy. So we can run subroutines like that. And we are going to look closely at this specific subroutine later. But I just wanted to show you this scoping thing, how that works. Alright, so hopefully you understand what subroutines are now. So now let's take a look at macros. So macros, what are those? Well, initially it might be easy to confuse them with subroutines, but they work completely different. So the subroutine, that's a pre-written routine somewhere, and we need to use JSR to run it, and then it runs and comes back and we continue the code. So just by using that little JSR command, it takes a tiny little bit of time. Now, it's not a big issue, so we're going to be using a lot of subroutines, but it would be faster if we just wrote that code 10 times in our program, like we talked about earlier. So it would be faster, but it would take up so much more space and you would have a lot of problems by doing it that way. So what does that has to do with macros? Well, macros is not exactly an assembly thing itself. So subroutines, JSR, those are assembly commands. Those are assembly things. Macros, that's something that the assembler, kick assembler in our case, that's something kick assembler allows us to do. So what is it? Well, let's take a look at an example here. So right here I've written my macro and a 2 here. So what's this all about? Well, if we take a look at this here at the bottom, I have defined something here. So it might not look too different from what the subroutine was, but there's a big difference, and I'm going to show you in just a second. But I defined something called my macro down here, and in kick assembler we do it by writing dot macro my macro, and we need a parenthesis. Then we can have an argument in here or not. But the point is, by using macros we can define a piece of code just like with the subroutine. So what's the difference? Well, first of all, let's take a look at this. Now the subroutine, I just ran that subroutine and then it came back when it was finished. So I didn't tell it to do I didn't give it any number, anything like that, an argument. I just say run that subroutine. When it comes back, it's finished. So everything is okay. Now with the macro, we can supply an argument in here. So right now I just call it my macro. It's not really a great example, but when I run this my macro, I should have given it a more, yeah, whatever. My macro and a 2 in here. So when I run this my macro, I don't just run it, but I also give it an argument number 2. So when it's run with a number 2 in here. So what does this macro actually do? This macro says LDA, whatever was in that number, load that and store it in 0400. You remember that memory address, right? The top left of the screen. That's what this macro does. So it's not a very exciting macro. But the point is that we can supply an argument with macros. So as I said, subroutines, we just run those and then they finish and come back. That's not going to change. We're always just going to run that subroutine. With macros, we run the macro, but oftentimes you want an argument to go with this. Okay, so here's the other difference. So macros aren't like subroutines. They aren't just a routine that we have some stored somewhere that we can run occasionally. When you use macros, like I did up here, I'm actually doing this. So when I use a macro, it's not like a subroutine where I just run it and it comes back. When I use a macro, that means well, somewhere in my code I defined that macro. Maybe it was 200 lines of code. So if this was 200 lines of code instead of just 2 lines of code, then wherever I used that macro, there would be those 200 lines of code. So for example, maybe I used this macro 4 times, which means that when I run this code into the assembler is going to translate here in my code where I said macro whatever, wherever I said the name of the macro. Now the macro here needs to be specified somewhere by doing it this way. Dot macro, my macro, and also starting and ending curly brackets. But the point was that every time I run my macro, I basically do this. So when I run it into the assembler translates the name of my macro, it translates this into what the actual code was when I specified it. So as I said, that means that if this macro was 200 lines of code, for every variable I wrote the name of the macro, that would be replaced with 200 lines of code. So already here you can see that even though it was just 2 lines of code, when I use the macros 1, 2, 3, 4, 5, 6 times, I used the macro 6 times here. And for every one of those times, this got pasted in there. Now we can't see this, of course, because this happens when we send the code to the assembler. So the assembler is going to do this for us. We're never going to see this, right? So it's going to look nice in our code. In this example. Okay, this isn't too bad. This is just two lines of code, right? 1, 2. So I just see 2 lines of code there. No. This is not just 2 lines of code. This is 4 lines of code when we start to run it. So it's one of those things that you have to think about what you're doing and why you're doing it. Now don't get me wrong, macros can be super useful, can be super handy, but we need to know when to use it and why we're using it. So let's take a look at an example. So here I am at my sprite macros. I have a separate file here called sprite macros. Now let me just quickly mention this as well. So I couldn't decide if I wanted to call our little guys on the screen sprites or objects, but I think it will cause less confusion if we just call them sprites and that's it. So when our guy is walking around the screen, we just call them a sprite no matter what. Alright, if you know what I mean, then great. If don't worry, we're gonna come back to those things. But we're in the sprite macros now. So our little guy walking around the screen, the enemies, whatever. I made a few macros here to make life easier for myself. So if you see the first one here, it says set sprite direction, and there's an argument in here for direction. What this macro does, it just sets the direction of the sprite. Next one says check sprite direction, and there's an argument for what direction we want to check. So I think this shows the point of macros. So now I just this is where I specify my macros. So this, what I've written right here, this isn't going to take up space in my code. This thing, but everywhere in my code, my actual code, everywhere when I run set sprite direction, the set sprite direction macro, everywhere when I run that code, that macro, everywhere I run that macro, that's going to be replaced with this piece of code. Everywhere in my code where I run check sprite direction macro, it's going to be replaced with this piece of code. So I can specify a million macros here, And as long as I just specify them like this, then they don't take up any space in my memory. They only take up space when we actually run the macro in the code itself. So hopefully that makes sense. But as you can see, and by the way, when we are writing macros, we should make them as short as possible, because of the fact that we are in fact, for every time we use a macro, we are in fact pasting that code in there. So we definitely should avoid having macros that are 200 lines of code, because if you absolutely need it and if you know what you're doing, okay. But as a general piece of rule, we make our macros as short as possible. And by the way, we can combine macros and subroutines. So if there's a lot of calculations that we need to do, then there's nothing wrong with, like for example, I do down here, check char collision. I use a macro because I want to have some X and Y offsets here. So I start my macro by setting those offsets, but then I run a subroutine at the end. So that means that every time I use this macro, it's just a few lines of code. Now, in the subroutine check char collision, that subroutine is quite a bit bigger, but that's just specified one place. So that's not going to be a problem with space, because every time I run this macro, I'm just going to use this. So 1, 2, 3, 4, 5 lines of code every time I use this macro, even though there's a lot of things going on in this subroutine. But by using it as a subroutine, then it's specified once in my code, and it's not going to take up any more space. It just takes up that space when I wrote it that one time. But of course, like I said, the macro is going to take up this space every time I use it. Okay, maybe it gets confusing if I explain it anymore, but hopefully it makes sense. So I just want to see the difference with by using a subroutine and a macro, and they both have their strengths. You can combine them like we see here. So once again, it's all about knowing what we're doing. What are we doing? Why are we doing it? So again, maybe this takes some practice to get used to it, these things. But hopefully you see what a macro is and what a subroutine is. And it's probably a good idea to just start experimenting with those two, to see if you can really see the point of making those things. Alright, well, I think actually that's enough for now. So hopefully you got this, macros, subroutines, and then we're ready for our next episode. So I'll see you then. Bye bye.